Okay, here's a second example here. Alright, so now we're not given the first term and the common difference. Here we're given the fourth term of an arithmetic sequence, that's 20. Alright, so we know a sub 4 is equal to 20, and also the 13th term is equal to 65. So, when you're given two random terms like this, there's different ways to do it. The most straightforward way would be to set up a system of equations using the nth term formula. So, that's, remember, a sub n equals d times n minus 1 plus a sub 1. Alright, and you should know that formula after using it a few times. So if we're going to do the fourth term, we're going to replace a sub n with 20, because that part would be a sub 4, which we know is equal to 20. Equals d, we don't know the common difference, but we do know n. Since it's the fourth term, we know that n is equal to 4, sorry. So 4 minus 1 plus the first term, which we don't know. Alright, and then simplify this down to 20 equals 3d plus the first term. Alright, and then I'm going to do the same thing with this value here. Okay, so I took this formula and I plugged in these values, 65 for a sub n, because it's the 13th term, and I plugged in 13 in for n. 13 minus 1 is 12, and I get 12d. So now I have to solve this system of equations here. Alright, one quick way to do it would be to multiply everything by a negative, because we already have the same coefficients with our first term. Add vertically, and we get 45 is equal to negative 9d. Alright, and we get d is equal to 5. So we get the common difference. To find the first term, just plug that in right there. And if you plugged in 5 for d, you would get 20 equals 15 plus the first term, which means the first term has to be 5. So now that we know that, we can plug that back into the formula. Okay, so I plugged in 5 and for d and a sub 1 into the formula. Alright, and then that simplifies down to 5n minus 5 plus 5. Oops, that's not a n there. And then that just simplifies to 5n. So that's our formula. So if I had to find the first several terms, alright, okay, I know the first term would just be 5, because that's 5 times 1. The second term would just be 10, because that's 5 times 2. The third term would be 15, alright, and so on and so forth. So when you're given two random terms in an arithmetic sequence, use the nth term formula and plug those in. Alright, and then same thing here, well, not same thing, but similar. Alright, we're given the first and the second term. Oops. The first and the second term. So, we could find the common difference right away and see that it's 7, because 9 minus 2 is 7. So our nth term formula would be a sub n equals 7, the common difference, times n minus 1, plus the first term, which is 2. Okay? So now, if I was looking for the 9th term, I would then plug in 9 in for n, and you get 7 times 9 minus 1 is 8, plus 2, so it's 56 plus 2, and you get 58 as the 9th term. So, just using a formula and understanding that arithmetic sequences have a common difference, very similar to a linear equation. Alright, now let's look at finding the sum of arithmetic sequences. Alright, so let's find the sum of the first 100 integers. So to do that, I'm going to write out 1, 2, 3, and then just do kind of like a dot 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 thing. Alright, my stylus is malfunctioning a little bit. Dot dot dot, and then we'll do like 98, 99, and then plus 100. Okay, so that would take a long time if you were just doing 1 plus 2 is 3, and then plus 3 is 6, and then plus 4 is 7. Eventually those numbers would get big, it'd be hard to do. And you could do it with a calculator, but that's a lot of numbers to plug in. But there's actually an interesting way to do this where it's really simple, and it's going to lead us to a formula. Alright, so since when you have an arithmetic sequence, there's a common difference. So like, to go from the first term to the second term, you add the common difference. And when you go from the last term to the second to last term, you subtract the common difference. So because of that, if you think of taking like the first term and the last term, you get 101. Then if you take the second term and the second to last term, since you add d to go from 1 to 2, and subtract d to go from the 99th to the 100th term, 2 plus 99 is equal to 101 again. Then you do the same thing with the next terms, 3 and 98, and you get 101. Alright, so I'm going to end this video, and then at the beginning of the next video, I'll show you what the sum is. But see if you can build off that logic and figure out what the sum of the first 100 integers is.